These are the notes for Algebra 2, Section 4.1, pages 236 through 239 in your textbook. Now we're looking at graphing quadratic equations or quadratic functions in standard form. Some definitions to go through first. First, a quadratic function can be written in the form y equals ax plus ax squared plus bx plus c. This is what's called standard form. Anytime we have this ax squared plus bx plus c, that's in standard form. A, b, and c are all numbers, and a isn't 0. This is standard form. Any other form is not standard form. So if you're asked to put something into standard form, that's what you're going to use. This is probably the most common way to see a quadratic function being written. Now, the graph of a quadratic function, as we know, is a parabola. We also know that the lowest and highest point on a parabola is the vertex. Now, the axis of symmetry divides the parabola into mirror images and passes through the vertex. This is useful information because we're going to use the axis of symmetry and its mirror imaging to make graphing these functions a little bit easier. Alright, so let's look at some properties of a graph in standard form. If we have y equals ax squared plus bx plus c, the graph opens upwards if a is greater than 0. It opens downwards if a is less than 0. So if a is a positive number, it opens upwards. If a is a negative number, it opens downwards. This is really similar to when we did absolute values. And when we did absolute values, we saw that if that a, that number in front, was negative, it opened downwards. And if it was positive, it opened upwards. There are going to be a lot of similarities between the two. Now, the graph is narrower than the graph of y equals x squared, the parent function, if the absolute value of a, that is the number of a ignoring the sign in front, if the absolute value of a is greater than 1, then it's narrower. And if the absolute value of a is less than 1, then it's wider. The absolute value of a being less than 1 means it's some fraction that's smaller than 1. 34th, 1/2, 2/3, something like that. Now the axis of symmetry, that we're looking for, can be found by saying x equals negative b over 2a. And we're going to work with that some in a few minutes. But for right now, we just need to know x equals negative b over 2a. And the a and b we get from ax squared plus bx plus c. The vertex has the x-coordinate negative b over 2a, which is not surprising because the axis of symmetry goes through the vertex. So they should share the same x value. The y-intercept for a function, a quadratic function in standard form, is c. That number c at the end is the y-intercept. So the point 0c, the point for the y-intercept, is always going to be on the parabola. Now let's use this information and some basic math to graph a quadratic function in standard form. We want to graph y equals negative x squared plus 4x minus 3. First thing we want to do, we want to identify the coefficients of the function. We want to identify the coefficients. Now, when I say we want to identify the coefficients, what I'm telling you is I want to find a, b, and c from ax squared plus bx plus c. So we have an understood 1 here, we have a 4 here, and we have a negative 3 here. A is the number in front of x squared, and it's negative 1. B, the number in front of x, and it's 4. C is the constant at the end, and in this case it's negative 3. Now because A is less than 0, the parabola opens down. Right? Negative 1, A is negative 1, negative 1 is less than 0, so the parabola opens down. Now we want to find the vertex. To find the vertex, first we have to calculate the x-coordinate. On our table that we just did, or our chart that we just did, we saw that the vertex is negative b, or the x-coordinate of the vertex is negative b over 2a. Now a is negative 1, b is 4, so I'm just going to start by plugging in those values. I have negative 4 over 2 times a is negative 1. So all I've done is plug in b and a. Now I need to actually work that out. 4 over 2 times negative 1 is negative 2. 4 over negative 2 is negative 2. Since it's negative, we have to change the sign. And if we were to plug this into our calculators, for instance, we would get x equals 2. Right? 4 divided by negative 2 is negative 2. Negative 2 is positive 2. Once we know the x value, we can use that to find the y value. And to find the y coordinate, all we have to do is plug our x coordinate into the function. So we're going to plug in 2 everywhere we see x up at the top. So I have negative 2 squared, and I put the 2 in parentheses, plus 4 times 2, again in parentheses, minus 3. Now again, if I type this into my calculator, or I work it out, 2 squared is 4, so I have negative 4, plus 4 times 2 is 8, so negative 4 plus 8 is positive 4. Positive 4 minus 3 is 1. So I've calculated my vertex now is the point 2, 1. And that's what it is. So I'm going to plot it here, 2, 1. I'm going to plot this point. I have a graph here off to the side. So I go to the point 2, 1 and plot it. Now I want to draw the axis of symmetry. And the axis of symmetry, I'm going to make a dotted line. And I'll draw it right down the center here. This is going to make my graphing easier later on. So I'm going to go ahead and draw it now. And when you're doing this on your own, you don't necessarily need to draw the axis of symmetry. But as long as you keep it in mind, life is going to be easier for you. Now, the axis of symmetry is at x equals the x value. And this line is x equals 2. The next thing we want to do is identify the y-intercept C. Easy enough. C is negative 3. That means that the point 0, negative 3 is on our graph. So I'm going to go to the point 0, negative 3, and here it is, and I'm going to plot a point. Then I'm going to reflect this point on the axis of symmetry to plot another point. So I'm going to use my axis of symmetry to mirror the point that I just placed. Since it's at negative 3, it's going to be at negative 3 on the other side. Since this point is 2 units away from the axis of symmetry, on the other side I want to put it 2 units away from the axis of symmetry. So 1, 2 here gives us this point. 1, 2 on the other side gives us the other point at 4, negative 3. All right. Next thing we want to do is evaluate the function for another value of x. So we're just going to pick a value of x, like x equals 1, and we're going to evaluate the function. That means we're going to plug in 1 for x everywhere we see it. So So I'm going to have negative 1, again in parentheses, plus 4 times 1 in parentheses, minus 3. Now we work it out. 1 squared is 1, so it's negative 1. Negative 1 plus 4 is 3. 3 minus 3 is 0. So I want to plot the point 1, 0. Right? Input, output. The input, what I put in for x was 1. The output that I got back was 0. So I'm going to plot the point 1, 0. After I do that, I want to reflect it just like I did before. Now, since this point is on the x-axis, the other point's also going to be on the x-axis. Since this point is 1 unit away from the axis of symmetry, I'm going to place the other point 1 unit away from the axis of symmetry. And there is my other point. And it is at 3, 0. All right, one last thing. Now I've got 5 points here, these two, and this one, the vertex and 2 others. And I want to draw a parabola using the plotted points. So that's what I'm going to do next. I'm going to draw a parabola as best I can anyway. Make it look something like this. My parabolas are never very good, but that's okay. There we go. Close enough. So here's the graph of the function y equals negative x squared plus 4x minus 3. Now we have one last thing that we're interested in, and that is minimum and maximum values. If I ask you to find, for instance, the minimum or the maximum value of the graph without necessarily graphing the function. And it's not so bad. We actually did it when we were graphing it. So it's just a part of graphing the function. Now we know, and we have a spot for the definition on the front of the note guide. The vertex's y-coordinate is the minimum value if the parabola opens upwards, and the maximum value if the parabola opens downwards. Now, we already know what that means because we've seen this before. The minimum value if a is greater than 0, because that's opening upwards. Opening upwards is greater than 0. And the maximum value if it opens downwards, which means a is less than 0. So in our 2 picture examples here, a is positive. Here it's bigger than 0, and I have a minimum. A is negative here, and I have a maximum.